Recording in progress. Hi, students. In this lecture, I am going to discuss problems. Let us see first one. See the data given. A block of mass 1 kg lies on a horizontal surface in the truck. The coefficient of friction between the block and the surface is 0.6. If the acceleration of the truck is 5 meter per second square, then find the frictional force acting on the block. This is the question asked in 1984 for 2 marks. Let us see how to start. So given mass is 1 kg and coefficient of friction 0.6, acceleration is 5, right? So you can try once if you want, then you can see solution. So first write down the given data. So there is a truck. Truck has acceleration 5 meter per second square. Given mu value. So mu in the sense it is mu s, it is mu k, both are same. If nothing is mentioned, mu value 0.6. Now there is a block. There is a block in the truck. Right, its mass given 1 kg. Mass 1 kg. So we have to calculate now frictional force. Right. So in the last lecture, we have discussed how to calculate friction. Right. So first step reference frame, next system, next taking free body diagram. Then we have to calculate normal reaction, next parallel force. Then we have to compare. Right. Let us see now in this case. First, let us solve the problem from truck frame. Imagine person is now in the truck. Okay. See with respect to him. So we have taken reference frame is now truck. Since the truck is having acceleration, means it is a non-inertial frame. So we have to take pseudo force. So we should take pseudo force. So first I'm writing here pseudo force. Acceleration right side, pseudo force is left side. That is equal to mass into acceleration. Mass is 1, acceleration is 5. Okay. Next, mg downwards. Normal reaction upwards, mg. If you take G10, mg, that is a down 10. Normal reaction n upwards. So first we got normal reaction. It is a 10. After having normal reaction, we have to calculate limiting friction. Limiting value mu s into n, right? In this mu s value 0.6, 0.6 into n value 10. So limiting friction is now 6. Okay. Next, calculate F parallel. Means parallel to contact. How many forces are acting and find net value. In this problem, there is only one force parallel to contact. That is pseudo force. So this is now F parallel. That is now 5 Newton. So now we have to compare. So this F parallel is less than limiting friction. Okay. So because of this pseudo force, block tries to slip relative to truck. Okay. Tries to slip left side. So friction will be right side. So F parallel is now 5, limiting value 6. That means block does not move. And we have learned that Static friction is self-adjusting. Therefore, frictional force, it is now static, which is equal to means magnitude, which is equal to F parallel. That is 5 Newton, right? So like this, we can solve the problem. Suppose if you want to solve same question from ground frame, let us see how to solve from ground frame. From ground frame, see where change comes. Forces that are acting on the block, mg, no change. Normal reaction, no change. Since ground is inertial frame, no pseudo force. Okay. And we can see that block moves only because of friction. Block moves only because of friction. So frictional force must be right side. Frictional force must be right side. Next. That means along horizontal, there is only one force on the block, that is friction. Now this friction may be kinetic, may be static. Now that we have to cross check. Suppose assume that block does not slip. Block does not slip. If block does not slip, then I can write here frictional force is now net force because mg balanced by normal reaction. Now only force is friction. This is now net force. Net force equal to mass into acceleration. Mass is 1 kg, acceleration is a 5. So this is now 5 Newton. So we got frictional force of 5 Newton, which is less than limiting friction. That means this is correct. It means the assumption what we have taken is correct. Okay. Suppose we got frictional force more than 6. That means assumption is wrong. That means assumption is wrong. Okay. I tell you here by taking, let us take, suppose in the question, let us say acceleration. Suppose acceleration is, take it as 8 meter per second square. Okay. Then see where change comes and take mu s value 0.6 and mu k value 0.5. Okay. Now see what happens. Again, from ground frame, normal reaction balanced by mg, no change in this. Okay. Coming to friction. If I am assuming that block does not move with respect to truck, then frictional force must be equal to, so here I have taken acceleration is 8. So 1 into 8. So frictional force is 8. But if you observe, limiting friction is now 6. How much? Limiting value 6. That means frictional force 8 Newton is not possible. Okay. That means block slips. Block slips. Since a block is slipping, friction will be now kinetic. So frictional force is a kinetic. That means the value will be mu k into normal reaction. That is mu k value 0.5. Normal reaction is 10. Okay. Or do one thing. Let us take a different value to avoid confusion. Let us take mu k different value. Take mu k value 0.4. Then this is 0.4. That means now friction is a kinetic which is equal to 4 Newton. So I hope you got a clarity. If acceleration is a 5, So what I have done in ground frame, I have assumed that block does not slip. In that case, friction is now static, acceleration equal to 5. So 1 into 5, it is a 5. And this value is less than limiting friction. Therefore, this is the correct answer. Now what I am doing is, I have taken different acceleration. Suppose truck is having acceleration 8 meter per second square, given mu s and mu k separately. Now if I take same assumption that block does not move, then answer is 1 into 8. Okay, but limiting value 6. So this friction is not possible. That means block is slipping. So I have taken it is a kinetic friction. So mu k into n. So answer is a 4 Newton. That means if you are solving from ground frame, you have to solve like this. Okay. Otherwise, if you want to solve from truck frame, then we have to focus pseudo force. Then pseudo force will be greater than limiting friction. That means parallel force greater than limiting friction. So body comes into motion and friction becomes kinetic. Okay. Let us see next problem. A uniform chain lies on a horizontal tabletop. If the coefficient of friction between the chain and the table surface is 0.3, then find the maximum percentage of the length of the chain that can hang over one edge of the table. So given mu value 0.3, maximum percentage of the length of the chain that can hang over. So hanging part we have to focus. Let us see how to start the problem. So there is a table and chain. Some part is hanging. Some part of the chain is hanging. Let us take total length is L. Now hanging part is small l. So we have to find small l by capital L into 100 is asking maximum fraction of the chain that can hang, right? Overhang. So see here, when chain is in equilibrium, we have to observe that weight of the hanging part is balanced by which force? Okay, I am repeating. We have to focus that weight of the hanging part of the chain is balanced by which force, right? So here you can see frictional force between the chain, the part of the chain on the table and table. Okay, there is no friction. This frictional force has to balance that force. Okay, that means when we are saying this is maximum length, when this hanging part length is maximum, chain has a tendency of slipping. Means chain is about to slip. So chain is about to slip means what I can write here, frictional force on that chain by the table, that is we can write mu s into normal reaction. This must balance weight of the hanging part of the chain. Weight of the hanging part of the chain. So mu s in the place of normal reaction, let us take total mass is m. Then m by L gives mass per unit length into length of the chain on the table. Okay. Into G. This is normal reaction. Mu s into this is weight of the chain on the table. M into G. This should balance weight of the hanging part of the chain. So why we are equating means chain is about to slip. About to slip means friction will be limiting value. Okay. So this weight is now again M by L, mass per unit length, into length of the hanging part into G. Okay. Now see here remaining calculation part. So here M by L cancel, G cancelled. Now what we have to calculate? I can take L here. L by L minus 1 is equal to 1 by mu s. Right? Then, and mu s value given 0.3. Right? Mu s given 0.3. This is 0.3 means it is 3 by 10, right? 3 by 10. It is a 10 by 3. Now, L by L is equal to, take 1 here, 10 by 3 plus 1. That is now 13 by 3. Okay. Therefore, what I can write here? Small l by capital L is equal to 3 by 13. And we want, okay, into 100. We want percentage, right? So small l by capital L into 100 is equal to 3 by 13 into 100. So this is our answer. Okay. So see the key point, what we have taken. Weight of the hanging part of the chain is balanced by limiting friction. Why taking limiting means it is about to slip, because we are saying maximum length of the hanging part. Okay, right. Let us see next problem. See the question given. A block of mass 2 kg is pushed against a rough vertical wall with a force of 14 Newton, coefficient of static friction 0.5, another horizontal force of 15 Newton is applied on the block in a direction parallel to the wall. Find the frictional force exerted by the wall on the block. So I have taken this question from H.C. Verma. Now see carefully. First note down the given data. If you want, try once of your own. Then see solution part. So first write down, we are pushing a block against a rough vertical wall. So rough vertical wall we have to take, or imagine we are standing in front of the wall. Let us do one thing. Consider you are standing in front of the wall. So now this is the block. That means now screen becomes wall. Okay. So we are standing in front of the wall and we are seeing the block. Therefore, this screen becomes wall. This is now block. See how many forces acting. First condition given that it is pushed against a rough vertical wall with a force of 14 Newton. So we are pushing. That means the force is now into, it is into the plane of the paper or into the board, right? So I'm showing the by dot. 40 is now inwards. Let us have 40 Newton. I'm marking as inwards. Inwards means just take notation as cross circle, okay? Inwards into the boat. Next, given coefficient of static friction, mu s 0.5. Remember, we are pushing the block with a force of 40. That means normal reaction will be 40 because wall exerts the same magnitude. See, block has no motion normal to the wall. I am repeating, block has no motion normal to the wall. Therefore, when we apply 40 normal to wall, wall also exert the same magnitude. That is a 40. So normal reaction is 40. Okay. Next. Now here we are applying a horizontal force of 50. Okay. And a parallel to wall. That means horizontal force of 50 is applied. 15. See carefully. It is a parallel to wall and a horizontal. I told you that this screen is now wall. Okay. Next, you can see weight acting vertically downwards. That means this weight also parallel to wall. Block mass given 2 kg. So weight becomes 20. Okay. Right. Now focus carefully the systematic way. So first focus free ball diagram. So we got applied force, EMG, normal reaction, right? After having normal reaction, calculate limiting friction. Limiting friction is mu s into normal reaction. Mu s into n. Mu s is a half, n is a 40. So it is now 20 Newton, right? Now calculate F parallel, right? So apart from friction, you can see this 15 and 20 both are parallel to wall. And between these two angle is now 90. So if I'm extending 15, direction part like this, okay? 15. Resultant of these two will be like this, right? Resultant of those two. See what is a value? Square root of sum of the squares. Because angle is 90 between those two, 20 square and 15 square, right? 400, this is 225, total 625. This becomes 25. Okay. So we got F limiting and F parallel. Now compare these two. F parallel is greater than limiting friction. That means block comes into motion. Block comes into motion. Therefore, friction will be connected. Therefore, friction will be connected. Now, in this problem, just given coefficient of static friction, right? Mu k value is not mentioned. So we are taking this mu s only mu k because that is not mentioned separately. Therefore, or do one thing, let us take a value for mu k. Suppose mu k value is 0.4. Okay. It is not given in the question, just I'm taking here. So you will get more clarity. So friction is now kinetic. Why kinetic? Because F parallel is greater than limiting friction. Therefore, block comes into motion. So kinetic, which is equal to mu k into normal reaction. Mu k, I have taken 0.4. 0.4. Normal reaction is 40 into 40. So this is equal to 16 Newton. That is now frictional force acting on the block. And what about direction? Okay. Direction will be opposite to the direction of F parallel. Direction of F parallel. Okay. I will show you here. So here, this is direction of F parallel. Friction will be exactly opposite to that. This is now direction of friction. It is Fk. Okay. So like this, we can solve the problem, means calculating friction in a systematic way. Free bore diagram, normal reaction, F limiting, F parallel, then compare those two. If F parallel greater than F limiting, block comes into motion, then friction is kinetic, then UK into N. If F parallel less than F limiting, then block does not move, then friction is static, which is self-adjusting. That means friction is balancing now this F parallel. Therefore, friction equal to F parallel. Direction is opposite. So like this, we can solve in a systematic way, right? Let us focus next problem. A block of mass m is placed on a rough horizontal surface. If the coefficient of friction is mu, then find the minimum force required to move it. Okay, it is given rough and horizontal. We have to find minimum force. So this is the question asked in 1987 for 7 marks. Let us see once. So we are placing on a rough horizontal surface. Placing a block. So one thing here, we cannot apply force horizontally because we are not knowing that whether it is a minimum force or not. So then what we are doing here, let us apply force at some angle with a horizontal. Okay. Suppose this angle is now theta, right? Now see free body diagram, mg downwards, normal reaction upwards. Now take components for this applied force. This is F cos theta. This is F sin theta. If you observe carefully, along vertical there is no motion. Along vertical there is no motion. Therefore, normal reaction will be equal to mg minus F sin theta. Okay. So for the block to move, condition is the parallel component is now F cos theta. This F cos theta should be greater than or equal to limiting friction, mu s into normal reaction, right? That is mg minus F sin theta. Okay. Now simplify this. F should be greater than or equal to mu s mg upon cos theta plus mu s sin theta, right? Now condition is we have to apply minimum force. We can see in this mu s mg, it is a constant. Coming to denominator, theta is variable. So by changing theta, we can change f value. That means if we can minimize denominator, sorry, if we can maximize denominator, then total value becomes minimum. Okay. So to make it maximum, what we have to do? Differentiate that and make it equal to 0. This is what we have learned in basic maths, right? While learning maxima and minimum. So d by dt, derivative of that with respect to variable. Variable is now theta. So derivative of cos theta plus mu s sin theta should be 0. because this should become maximum. When this is maximum, total value becomes minimum. So derivative minus sine theta plus mu s cos theta equal to 0. Okay. From this, what we can write? I'm taking sine here. Then we get mu s is equal to sine by cos. It is a tan theta. And we have learned that coefficient of static friction is equal to tangent of angle of friction. So I can write here in the place of this tan alpha, where alpha is angle of friction, that is equal to tan theta. That means if angle of this angle theta is equal to angle of friction, then we can move the block with minimum force. Okay. So keep this point in mind because we apply this one in remaining problems. Okay.